How well does the simple collision theory match experiment, and what can we learn from this theory? Recall that the simple collision theory rate constant consists of a pre-exponential portion and an exponential portion that tells us about the fraction of collisions that have enough energy to react. As it turns out, we cannot really calculate rate constants using this equation because this activation barrier is not easy to calculate from first principles. However, what we can do is compare the simple collision theory pre-exponential to a measured pre-exponential factor and learn some information about the reaction. The only part of the pre-exponential from simple collision theory that we cannot calculate from structural information about the molecules is the orientation factor, the percentage of collisions that have the right orientation to react, which we've given the symbol P. If our simple collision theory is relatively accurate, then we would expect this pre-exponential to match the pre-exponential factor that we measure experimentally. So if we take the experimental pre-exponential factor obtained from an Arrhenius analysis of the rate constants as a function of temperature and divide through by everything that we can calculate from structural properties of the molecules, we see that we can calculate the percentage of molecules which have the right orientation to react. Thus, by comparing the simple collision theory to experiment, we get a sense of the steric requirement for a given reaction. The larger P is, the larger the percentage of collisions which have the right orientation to react. The smaller P is, the lower the percentage of collisions which have the right orientation to react. When P is equal to 1, or the simple collision theory predicted pre-exponential equals the experimental pre-exponential, then all collisions have the right orientation to react.